Oh, here, I'm sorry. There you go. So when we say system, we're talking about two or more equations with two or more variables. What that means, a solution is where the lines or where the graphs intersect. We talked about this in chapter two, one in chapter two, I forgot. If you have two lines, if you have two equations, there could be four possibilities. Here's line one, here's line two. They could be parallel. If they're parallel, they have no solutions because they don't cross. They could be the same line. I'm sorry. They could be the same line, which means they have infinite solutions. Every point is a solution. They can form a 90-degree angle. We call that perpendicular. We only have one solution. And we have any other. This is line one, line two, and this one here, line one, line two. Where they intersect, that's your solution. And this one only has one solution also. And we talk about, well, how can we see this happening by looking at the equations? On this side here, these two equations here, the slopes of the two lines have to be the same. The only difference are the y-intercepts. If they have the same slope but different y-intercepts, that means they're two different lines. They have two different equations. If they have the same slope, same equation, they're the same equation, same graph. And on these last two, perpendiculars have negative reciprocal slopes. And the last one is if they just have different slopes, there's nothing we can do about it. They're going to have one solution. So those are the four possibilities. But then again, we also can have other type of graphs, because what if we had one graph was a parabola and another one was a line? This one has two possible solutions. Or it could have one possible solution. Or it could have no solutions. So it all depends on what your equations are. Just you have to set them equal to each other to solve for the two equations. Depending on which one of, if you notice, we have three basic differences here. Either there's one solution, infinitely many, or no solutions. Look at your sheet. Depending on that condition, on which ones it is, they have different names. If they intersect and have one solution, those are called consistent and independent solutions. The two lines are independent of each other. That means they're going to cross. They're consistent, meaning that they have one solution. As opposed to if they're parallel, they're inconsistent, meaning they're not going to cross, and they're inconsistent and they're independent, meaning that they're going to do what they want. And one doesn't affect the other. And the last one, if they're the same line, they're going to be consistent because they have solutions, but independent or dependent. I mean, whatever one does, the other one does. So consistent and dependent. Inconsistent, independent, consistent, independent. So if it has a solution, it's automatically consistent. So the consistent part tells me, do they have solutions? If it has no solution, then they're inconsistent. If they have at least one solution, they're consistent. Independent means that they're individual lines. Dependent means they're the same line. So there's no easy way to memorize that. It's just, I'd write it down somewhere, have quick access to it. There are four methods to solve systems of equations. There are four methods. One is substitution. One is elimination. One is graphing. And the other method is called Cramer's rule. Uses what we call matrices. The easiest of the bunch is graphing, because we spent so much time graphing these things. So let's look at we're going to use the same equation for all four of these. Okay, let's solve using graphing. And the limitation of graphing is only as good as your graph is. So how do we graph these two equations? Well, we're used to graphing. They have to be like this. Since they're linear equations, they have to be like this. If they're quadratic, then we find the x-intercepts, find the vertex. If they're cubic, but since these are both linear, y equals mx plus b. So for the first one, since I need to have y positive, I'll move the y over there and the 5 over here. So I have y is equal to x minus 5. I add y to both sides, I subtract 5. And this one, I got to move the 2x over, so it's minus 2x plus 1. Let's go ahead and graph both of these on the same picture. So on the first one, when x is 0, y is negative 5. What's the slope of the first one? 1 over 1. So go up 1 over 1. Connect those dots. That's line 1. The second one, we plot the y-intercept, which is positive 1. Follow the slope down 2 over 1. Connect the two. And I'm guesstimating my solution is going to be at where? I'm saying my solution is going to be at 2. We'll see. Exactly. That's exactly it. It's depending on how unless you have graph paper, because unless all your boxes are the same distance apart, that's why it's going to be pretty close. So obviously graphing, unless you have a graphing tool, it's going to be the last one you want to use. Okay, so that's graphing. The next method we're going to look at is substitution. Here are the steps for substitution. Choose either equation, L1 or L2, doesn't matter which one, and solve for a variable. So which one do you want to use? You want to use the first one or the second one? Okay, so we have x minus y equals 5. Let's go ahead and solve for x. So we add y to both sides. So x is equal to y plus 5. We have to come back to this one. Now, substitute that equation into the other equation that you didn't use. So the other one we didn't use was 2x plus y equals 1. So anywhere I see an x, I put a y plus 5. Because x equals y plus 5. So anywhere I see an x, I put a y plus 5. The third step is going to be solve for the remaining variable. So we have 2y plus 5 plus y equals 1. You see what you're getting? 2y, 2 times 5 is 10. 2y plus y is 3y. So I combine those two. Subtract 10. 3y equals negative 9. So y is equal to negative 3. So far, so good. That's what our picture said. What do we do with that? Yes. Now plug that solution into the equation from step 1. So we see the x value, and we see a y is negative 3. So x is equal to 2. The point of intersection is 2, negative 3. It's the solution. So far, so good. We'll do a couple more of these examples, so don't worry about it. The third method is elimination. So we have x minus y equals 5. 2x plus y is equal to 1. And here are the steps. Put both equations into standard form, which is ax plus by equals c. And check. So x, in other words, what else is x and y on the same side? Second step. Choose a variable to eliminate. They must have the same coefficient, but opposite signs. So we look at our equation. One we get rid of would be obviously y, because this is the elimination method is also called the addition method. Because what we're going to do now, we're going to add the two lines. Add both equations. So we got x plus 2x is 3x. The y's cancel. 5 plus 1 is 6. So add the two equations and solve for the variable. So there's one part. Now, because we used both equations at the first step, it doesn't matter which one you plug that one into. So step 4 is plug that value into either equation and solve for the remaining variable. So it does, since I used both of them at the beginning, I can use, so I would use a second equation. I'm using equation 2. 2x plus y equals 1. X is equal to 2, so I'll plug that in there. Now I got to solve for y. Subtract 4 from both sides. Y is equal to -3. So my solution, the point of intersection, is at 2, -3. That's my solution. Yeah, we'll stop here today because I want to do another set of examples on each of these 3 methods, and then we'll do at least one more, maybe 2 more, and then we'll finish up doing the Cramer's rule. So we'll finish up next time for sure. You guys can smell the end of the semester, and I'll show you. Let me